Alright guys, welcome back to Algebra 2. What we're going to be talking about today is theoretical probability. Now what you're going to have to do is you're going to have to skip forward a whole lot of pages in your packet. We left off with combinations and permutations, which was the first page. We are skipping pages 2 and 3. At least we're skipping the front side of 3 and going to this page right here. Hopefully it shows up on screen there. It's labeled theoretical probability. It is the back side of the third page. So theoretical probability talks about how likely is something to happen, right? We've been talking about permutations or combinations, you know, the number of different ways something can happen, but it's time that we talk about what are the chances it will. So simple probability, or simple events, the first section of this, really just talks about, in a single event, there's a whole bunch of outcomes, right? All the different ways the event can go. And to determine its probability, we take the number of successful outcomes, the number of outcomes that we're okay with or that we want, whatever it is, divided by the total number of possible outcomes. So let's say we're rolling a dice, right? A 6-sided dice. And we want to roll an even number. Well, of those 6 sides, how many of those would be a successful outcome if we want to roll an even number? 3, right? 2, 4, and 6. Those would all be successful. Out of 6 total possible outcomes, because the dice can only land in one of 6 ways. So, let's take a look at an example here. Number 1 says a jar contains 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? Well, let's think about this. We need to fill out both of these. So the number of successful outcomes. We want a red marble, and how many red marbles are there? 32. So the number of successful outcomes is 32. But how many total outcomes are there? How many different marbles could you pull out of that bag? Well, if there's 32 red ones and 28 blue ones, then in total, if we add those together, there's 60 marbles in the bag. So 32 out of 60. That's a fraction that we can simplify, right? We can break that down. Both of those numbers have 4 in common. If we divide each of these by 4, we get 8 out of 15. That's the probability of us drawing a red marble from that bag. So again, the number that we consider successful, the number of ones that we want, divided by the number of possible ones that are there. So if we look at number 2 says a letter in the word restoration is randomly selected. What is the probability of selecting a vowel? Well, let's see. Restoration has how many letters? 4, 5, 6, 7, 8, 9, 10, 11 by my count. Hopefully that's not wrong. If we have 11 total letters, we could randomly choose from this word, and we want a vowel. So what we want is considered our successful outcome. So there is an E, an O, an A, an I, and another O. 5 of them, right? 5 of these numbers are vowels. 5 are what we would consider successful in our experiment out of 11 total. So that would be our probability. What I want you guys to try out, number 3, 4, 5, and 6. See how those go. If you have any questions, feel free to shoot me an email. Otherwise, I'll see you guys tomorrow.